Hello everyone. This is the second lecture on plastic processing. In this lecture, we will discuss on three topics, that is injection molding, blow molding and thermoforming processes. So first of all, we will start with injection molding process. Injection molding process is a molding process where plastic materials are softened, or it is heated and then it is softened and then it is forced to flow through a nozzle into the mold cavity. The plastic Then the plastic solidifies in the die and then it is ejected by opening the die. The cycle time for this process is very less, that is around 10 to 30 seconds. Now, as the cycle time is very less, so the production rate is high in this process. The injection molding pressure usually range from 70 MPa to 200 MPa, and most polymers, that is the thermoplastic materials like fiber reinforced thermoplastics, thermosetting plastics, and elastomers, all these type of polymers can be injection molded. Now, by using this process, very complex shapes or very complex parts can be produced whose size may be range from 50 gram to very large size, that is around 25 kg, with excellent control of tolerances. So that is the introductory part of injection molding. Next, we will discuss what are the parts in the injection molding process. This is the constructional feature of an injection molding machine. In this injection molding machine, you can see there are two parts. One is the injection unit, another one is the injection unit, another one is the clamping unit. In the injection unit, there is a reciprocating screw. That's why this injection molding machine is called as an injection molding machine with a reciprocating screw. Here you can see there is a cylinder for screw ram. These are the gears for transmitting the power from motor to the reciprocating screw. So here the screw reciprocates and the plastic materials are moved towards the nozzle. So through this feed hopper, the plastic materials are placed into the barrel, and in the barrel there are heaters are connected. Now these heaters heats the plastic materials and it softens the plastic materials. Then these plastic materials are, then a force is applied on these plastic materials with the help of this reciprocating screw, and at that time reciprocating screw acts as a ram. So when the reciprocating screw moves in the clockwise direction, when it rotates in the clockwise direction, it moves in the forward direction, and when it moves in the forward direction, it applies forces on the softened plastic materials, and then it applied forces on the plastic materials, and the plastic material passes through this nozzle into the mold cavity. This is the non-return valve. This non-return valve ensures that no plastic material will come back with this threads of the screws. So this is the purpose of this non-return valve. Then the plastic materials are forced through this nozzle into the mold cavity. Then it reaches to the clamping unit. So this is, one is the injection unit, second one is the clamping unit. In clamping unit, you can see there are two platens. One is the stationary platen, another one is the movable platen. In the stationary platen, one half of the mold is connected, and in the movable platen, other half of the mold is connected. So after the solidification takes place, then this movable platen moves along this side, and when it moves along this side, then we can eject the finally molded material. So that is the total process of injection molding. Clear? Next, we move to the different injection molds that are used in injection molding machine. So basically there are two types of injection molds. One is the cold runner mold, another one is the hot runner mold. In the cold runner mold, there are two types of mold. One is the two plate mold, another one is three plate mold. Two plate mold means there will be two plate. One platen is for the stationary platen, second plate is for the movable platen. And in case of a three plate mold, there is another plate that is in between the stationary platen and in between the movable platen. That plate is called as intermediate plate. Okay. Next is the another one is the hot runner mold. So this is cold runner mold and this one is called as hot runner mold. Now why it is called cold runner mold? Because in the cold runner mold, the runner, sprue, all these will be solidified. But in the hot runner mold, the runner, sprue, those are not solidified. That's why it is called as hot runner mold. In this case, always the material in the passage of sprue and runner will be in the molten state. Okay, that's why it is called as hot runner mold. Next, we will discuss on two plate mold that is used in injection molding machine. So in the two plate mold, these are the schematic diagrams of the two plate mold. The first two plate mold is where there is only a single cavity. So here you can see this is a single cavity. This is a nozzle. This is the sprue, means this is the passage through which the plastic melt will pass through this sprue and it will move towards the mold cavity. This is sprue bush, and here after the completion of the injection molding process, this is the movable platen, so it moves along this side. Then we can eject the final product. So it is called as two plate mold with a single cavity. Only a single cavity is there. That's why only sprue is there. Now if there is two cavities, in that case we will be needed a runner. So when there is a two plate mold with a multiple number of cavities, in that case this is the sprue, and after passing through the sprue, the plastic melt should have to pass into the multiple cavities. So in that case it will pass through the runner and it enters into the mold cavities through the gates. So that is called as two plate mold with multiple cavities. So after the end of the process, the movable platen will move and then we will get the final product. Now in this final product, this is the final product, these two are the final product, and this is the sprue, this is the runner, and here it is the gate. So this runner and gate will be remelted again, and then we can use this plastic material for the next cycle again. So that is called as two plate mold with multiple cavities, and this one is called as two plate mold with single cavity. So in the two plate mold, as in this two plate mold, you can see this is the stationary platen, this is the movable platen. Here this is the ejector housing, this is ejector plate, this one is ejector pin plate, and these are called ejector pins. All these four are called as ejector pins. Now from the nozzle, the plastic melt will pass through this sprue, then through this runner it enters into the mold cavity. Runner, and then at this portion there is a gate. So you can see in the two plate mold, the gate is attached at the side of the mold cavity. Okay, so this is the molded part or mold cavity. At the side of the mold cavity, the gate is situated, and through the gate plastic melt will enters into the mold cavity. Now as as you know, the cycle is around, the cycle is around, it is around 10 to 30 seconds. For completion of the one process, it will take around 10 to 30 seconds. That means if we can cool the plastic, if we can cool the molded material quickly, then the cycle, means the total completion time for one molding will be much more less. That means we can perform some more injection molding uh, within the same period of time. So these are called as water channel, through which water is supplied. So as when the water is supplied, so the solidification of the plastic melt will take place quickly, so that the total cycle of the process will be less. That's why these channels are provided, these water channels are provided. Next is, so after, during the the solidification process, due to the natural shrinkage, what will happen, the due to the natural shrinkage, the plastic melt will be, so due to the natural shrinkage, the plastic melt will be solidified, and then it will stick to the end of this ejector pin. So when the movable platen will be open, means when it will move along this side, along this direction, then the final product will move with the movable platen, and we will get the final product, or we can eject the final product after the end of the process. So here, two plate mold with multiple cavities showing the ejector plate and the cooling channel with the mold opened. Okay, so this is called as two plate mold system. So basically in the two plate mold system, there are two plate. One plate is the stationary platen, another one is the movable platen, and here the final product will move with the movable platen at the end of the process. And another important is, in two plate mold, the plastic melt will enter into the mold cavity through the means the gate is situated at the side of the mold cavity in case of two plate mold. Now coming to the three plate mold. In the three plate mold, you can see that the gate is situated at the base of the mold cavity. So this is the mold cavity, and in the mold cavity at the base, the gate is situated in both the cases. So this is the example of three plate mold with multiple cavities. So in the three plate mold with multiple cavities, plastic melt will enter into through the nozzle, then it enters through the sprue, then through the runner, then through the gate it enters into the mold cavity. Okay, now at here, this is the intermediate mold plate. This plate is called as a intermediate mold plate. Now another thing that I forget to tell you, that in two plate mold there is some clearance into the hole of this ejector pin. Now due to the clearance of the hole in this ejector pin, some air can come in to the plastic melt. Now to eliminate that air from the plastic melt during the solidification, some holes must be, or some air vent must be at the parting surface of the mold. This is the parting surface. So at the parting surface of the mold, there should be some air vents, and the size of the air vents is around 0.03 mm deep and 12 to 25 mm wide. So similarly in this three plate mold also, there should be some air vent at the at the parting surface. Okay, so at the end of the process, when the when the movable platen move along this side with the movable platen, the final product will also move in. Now in the three plate mold, what will be happen that in the three plate mold, what will happen that in two plate mold the plastic melt enters through the side, possibly, and it possibly creates a weakness at the weld line. But in case of a three plate mold, it enters into the three plate mold through the base of the mold cavity. As a result, there will be a even distribution of melt into the sides of the part. That's why three plate mold is more preferable than the two plate mold. Now at the end of the semester, sorry, at the end of the process, when the when the movable platen moves along this side with the movable platen, the mold, the final product is also moves with the movable platen, and the sprue and runner, at that time the sprue and runner is separated from the final product. But in the two plate mold, it is not separated due, it is not separated from the final product, but in the three plate mold it is directly separated from the final product, and it is solidified also. Now when it is solidified, after the solidification, again if you have to use this sprue and runner in the next cycle, then again you have to melt it for the next cycle. Now there is another process that is called as hot runner mold. In the hot runner mold, what will happen that sprue and runner will add in that place, always the material in sprue and runner will be in the melting stage or in the molten state. As a result, we don't need to melt the sprue and runner again for each of the cycles. So what will happen that at the end, in the next cycle, the plastic melt that is situated in the sprue and the runner will automatically get into the mold cavity in the next cycle. So that is the concept of hot runner mold. Next we will move to the blow molding. In the blow molding is a process, it is a process where the air is, it is a process to manufacture a hollow parts that includes the plastic bottles, toys, air ducts for automobiles, chemical and gasoline tanks, etc. can be produced using this process. Now the cost of blow molded parts is higher than that of injection molded parts, but the tooling costs are lower compared to injection molding. So what is that blow molding process? There are three types of blow molding process. One is the extrusion blow molding, another one is the injection blow molding, and third one is the stretch blow molding. So first we will discuss the first one, that is called as extrusion blow molding process. In extrusion blow molding process, there is an extruder, and from this extruder we get a plastic material that is called as Paddison, and through this extruder we will get the softened plastic material in the form of Paddison, or it is also called as preform. Then that softened plastic material enters into the mold, it enters into the mold, and then the mold will be closed, and there is a blow pin. This blow pin will be attached here, and through the blow pin air will be introduced into the mold cavity. So when air will be introduced in the mold cavity, the Paddison takes the shape of the mold cavity. Okay, so then after it takes the shape of the mold cavity, then the mold opens and we will get the final product. So in this process, the first is hollow Paddison is formed with extruder. All of you know the extrusion process of plastic processing. So by using that extrusion process, that hollow Paddison is formed. Then that hollow Paddison is in that the mold closes around the Paddison and blow pin inserted, and then air is blown into the Paddison, thus expanding it to conform to the contours of the mold, and at the end the mold opens and the finished part is removed. Okay, so this is called as extrusion blow molding, as we are getting the Paddison from the extruder barrel. That's why it is called as extrusion blow molding. And it is blow molding because we are blowing air into the Paddison to give it a shape of the similar to the mold cavity. So this is called as extrusion blow molding process. Okay, next we will move to the injection blow molding process. So injection blow molding process is it is also a similar type of blow molding process. The only difference is in injection blow molding process, we means we produce the Paddison, or we in the injection blow molding process we produce the hollow Paddison with the help of injection molding process. So in the injection molding process, as we know, how we provide the plastic melt into the mold cavity. So suppose this is the mold cavity and this is the screw. Suppose now with the help of the screw, it will be the plastic melt will be forced into the mold cavity, and when it will be get into the mold cavity, it takes the shape of the hollow Paddison. Then it will be transformed. It will be transferred into the mold cavity, and this total portion will be transferred into the mold cavity. And then after the transfer into the mold cavity, then air will be blown into the through this blow pin into the Paddison, and after that when air comes into the Paddison, it applies the pressure and the Paddison takes the shape of the mold cavity. So the first step is hollow Paddison is formed in the injection mold. Second step is Paddison with blowing rod is transferred to the blow mold. Third step is air is blown into the Paddison, thus expanding it to conform to the contours of the mold. And step number 4 is the mold opens and the finished part is ejected. So this is called as injection blow molding, as we are producing the Paddison with the help of injection molding process. That's why it is called injection, and blow molding because we are blowing air to give the Paddison into the shape of the mold cavity. That is called as injection blow molding process. Next, we come to the stretch blow molding process. In stretch blow molding process, when there is an injection unit, and through this injection unit we inject the plastic melt into the mold cavity, and then we form the hollow Paddison, and then this hollow Paddison is taken into the hollow Paddison with this blowing rod is taken into the mold cavity, and then air is blown into the Paddison, thus expanding it to conform to the contours of the mold. Okay, so this is called as stretch blow molding. Okay, next we will move to the thermoforming process. In this process, a thermoplastic sheet can be formed into a three-dimensional shape by the application of heat and differential pressure. That means in thermoforming process, at first we have to heat the plastic sheet. Then that plastic sheet, we will provide a differential pressure on that plastic sheet, so that it can take the shape of the mold cavity. That is called as thermoforming process. Now it is used for making parts such as cupboards, displays, trays, drinking cups, and food packaging. Okay. Now there are three types of thermoforming processes. One is the vacuum thermoforming process. One is the pressure thermoforming process. Another one is a drape forming process. So the first one is a vacuum thermoforming process. In the vacuum thermoforming process, as I told you at first, the plastic material is heated, and generally infrared heating is generally used to heat the plastic material. Then the plastic material is heated, and then that the softened plastic material is placed into the it is held with the clamps, and then you can see in the mold cavity there are some vacuum holes are there. So through these vacuum holes, the air that is present inside this mold cavity is sucked, or it is withdrawn through these vacuum holes, and through these vacuum holes the air is withdrawn from this mold cavity, so that the plastic melt, or the so that the softened plastic will take the shape of the mold cavity. So the vacuum is drawn. So during the vacuum drawn, the plastic material takes the shape of the mold cavity. Okay, so it is called as vacuum thermoforming process. So in the first step, plastic sheet is clamped in a frame and heated. Second step is heated plastic sheet is attached to the mold. Third step is vacuum is applied, drawing the plastic sheet to follow the contours of the mold. And the fourth step is the part is released. Clear? These are the four steps of vacuum thermoforming process. Next, so here it is the three-dimensional view of a vacuum thermoforming process. These are the clamps, this is the plastic material, these are the heaters, and then this is the mold, this is the vacuum pump, and this is the finished product after the end of the process. Next is the pressure thermoforming. In the pressure thermoforming, we use both the pressures, means we use air pressure as well as the vacuum pressure. So in the pressure thermoforming, at first, similar to the previous process, the plastic material is clamped and then it is heated, and after the plastic material is softened, then air is supplied, so that air pressure supplied on the plastic material, and at the same time vacuum is drawn with the help of the vacuum pump. So as a result, due to the vacuum drawn with the help of the vacuum pump and the applied air pressure, it takes the shape of the mold cavity. Okay, so in this process the steps are: the first step is plastic sheet is clamped in a frame and heated. Second step is the heated plastic sheet is attached to the mold. Third step is pressure is applied on the top, forces the plastic sheet to follow the contours of the mold, and vacuum is applied from the bottom to assist the forming process. Okay. So in both these thermoforming processes, we are using the negative molds. In both these thermoforming processes, we are using the negative molds. Now we will discuss a thermoforming process where we will use positive mold. Next, this is the drape forming, where in this drape forming we use a positive mold. In the drape forming, we will heat the plastic sheet. We will heat the plastic sheet, and then that heated plastic sheet is, then we will apply a force. Then we will apply the force so that the plastic sheet will take the shape of this positive mold. Okay. So in this process, the sheet is first framed and then it is heated. Then it is mechanically stretched and pressure differential is then applied to form the sheet over a positive mold. In this case, however, the sheet touching the mold remains close to its original thickness, similar to cup forming of sheet metal as explained in our earlier cases. And it is possible to drape form items with a depth to diameter ratio of approximately 4 to 1. Okay, so basically in the drape forming, we use a positive mold, and in the vacuum thermoforming and pressure thermoforming, we use negative molds. So this is the end of the plastic processing processes, and all the plastic processing processes that we discussed, that is based on different thermoplastic materials, and and means we generally give the thermoplastic materials with the help of this plastic processing processes. And uh, you can go through the advantage and the disadvantage of extrusion blow molding, injection blow molding, stretch blow molding, as well as you should go through the advantage and disadvantage of injection molding process, as well as extrusion molding process also. So this is the end of the plastic processing chapter. Thank you.